There are six parts to physics: mechanics, electricity, waves, materials, fields, and atoms. So now we're on part two, which is the electricity. And we are starting off with charge and current. Okay, doke? Yeah? Yeah? No? Did you write this down, Grace? Yeah. Yes? Okay. Okay. Some of this might remind you of what you did in chemistry. Maybe. So from chemistry, or even just basic middle school science, you might remember that electric charge is something basic to electrons and protons and other things too. But protons and electrons have an electric charge. Now you would have done this in chemistry, right? So electrons, we say, are negatively charged, and protons positively charged. Things that are negatively charged and things that are positively charged attract each other. So if something is negative and something is positive, what will happen? They'll attract. This is how you get, your proton and your electron together. But if they're the same charge, what happens? They push away. So positive and a positive, no, pushes away. A negative and a negative pushes away. This is called the law of charges. So you can write. Got this? Not yet. Does anybody watch the news about the Irish election? No, no interest.
Why?
It's not finished yet. They're not finished counting. No. Election, government.
Oh, no.
Definitely no, huh?
I don't know where to look, and I don't know who is who.
That's okay.
Remember some pictures.
Just remember picture. There are many real men and women.
And both
Many.
McDonald's one.
Very good.
And last time I working, and see very big car and
Oh yes,
and
big car. Yes,
yeah,
big poster.
yeah,
Yes.
and there's music
Yes,
very loud.
sure. Yes.
And then some people plus one. And
Plus one. Yes.
And I was taking a phone and I have to work opposite way.
Yes. Too loud. No one important.
Who is important?
Who's important?
Who do you think is important?
I guess we don't McDonald's.
Honestly, none of them are important.
Mm.
They think they're important.
Mm.
They're not though. Okay, continue.
Yeah.
Yep.
Not for you?
Important to me?
Yes.
A little important. Not much.
Like some.
Just a little. Okay.
Who do you vote for?
The current government.
Who's the current government?
Who's the current?
The name Fine Gael. Fine.
Oh.
This one.
What's
Gael.
number?
Is it the guy, the black and white guy with green name?
Black and white guy with green name. No, I don't think so.
You don't
Their
know
colours,
about
their
it?
colours are usually dark blue.
Oh.
Blue.
Oh, blue.
The blue. Look at the blue one. The dark
Yeah.
blue. Yeah.
What's the number?
I think they have
Vote one.
47 seats.
Maybe.
Yeah.
So look at the blue.
Look at blue. Look at the blue ones. Yeah. Okay. In chemistry, have you done charge? Positive and negative charge.
Yes.
Yeah. Have you done current?
No.
Maybe.
No.
We haven't.
Okay. So current is when the electric charge moves. So current is the flow of electric charge. Okay, so can you get this definition?
It's always opposite, right?
Huh?
It's opposite, right? Like if the current is this way, the the charge is like this way. The electrons move this way.
Yes, all of that we'll get to in time. Continue?
Yeah.
No.
No, my goodness, it's only one sentence.
And actually write very beautiful.
Ah, beautiful writing, yes. Not like me. Continue?
Yeah.
Oh, did you hear about your active listening?
What?
Your active listening.
What is active listening?
What is active listening?
Yeah, what do you mean?
You don't know about this?
No.
Alright, I won't say anything.
Okay.
What?
Later.
No.
Later.
It's
Alright.
we are being
Later.
Please then.
In a metal, it is free electrons that flow. So you've heard this in chemistry, free electrons. These are in a metal. They're free to move. So like here's a simple little picture of the electrons are moving in the metal. I think sometimes you hear it like a sea of electrons, an ocean of electrons. Free electrons, they move in the metal. And you can draw that if you want. A simple picture.
We got the idea.
You got the idea, yeah.
That is true.
It's okay, it doesn't matter. Just write down free electrons for a metal. Like here is a wire. Got that?
Yeah.
So here, if there's a current, it's because the electrons are moving. The negative charge is moving. Yeah? Okay, an electrolyte is a chemical that conducts electricity. It is used in batteries to make ions flow, producing current. Ions are just atoms with an extra electron or a missing electron, therefore making it negative or positive. So again, this is something that you probably have seen in chemistry. In this picture here, the positive ions move to the right and the negative ions move to the left. So this is an electrolyte. In an electrolyte, the ions move. Okay? Now, have you done something like this in chemistry?
In high school.
In high school. You will do something like this with Lorraine. Words like ion. Have you done ions?
Yeah.
Yeah. So Ions just mean that has an extra electron or is missing an electron, as you know. So here for an electrolyte, the ions move in the liquid. Not the electrons, not the protons, the ions is what carries the current, the charge. Okay, so can you get this definition as well, please? You don't need to write down what an ion is if you know what an ion is. You all know what an ion is? Then if you know what an ion is, you just need to write this much. Got this? No. Yeah. I need to continue.
Diagram picture.
No. Continue?
Yes.
Okay. So here, which way do we say the current flows? So,
From positive to negative.
positive to negative, negative to positive. So, which way does the current flow?
Positive to negative.
From positive to negative. Yeah? Bad news, yeah. Both, kind of. So which way does the current flow, or maybe I should have been clear, which way does the electrons flow? So let's be clear what I mean here. In this picture, there, can you see on the left is the battery with the plus and the minus? Okay? The electrons are the thing that moves in the metal. The electrons move. So in the picture, the electrons go down, right, up, left, and back. The electrons go like this, okay? But we say the current moves up, right, down, and left. And you might be thinking, well, why do we do that? Why, if the electrons go this way, why do we say the current flows the other way? You know, it's just unfortunate. That's the way it is. By current, we mean positive to negative, but electrons, they flow from negative to positive. So it's opposite. So you need to be careful with your English. If I say current, I mean positive to negative. But if I say flow, electron flow, it's negative to positive. So we always say the current flows opposite to the electron flow. The current is opposite the electron flow.
But actually it is the electron.
It's the physical electron that's moving,
Yeah.
but we say the current is moving in the opposite direction.
But in reality, like it's from the current is from negative to positive.
No, well, see, that depends what you mean by reality. The electrons flow from negative to positive. This is really what's happening, but mathematically, we say that the current is flowing from positive to negative, even though there's nothing physically moving that way. It's how we think about it.
Yeah.
Okay, continue. So if an electron moves from A to B, we say the current flows from B to A. Yes, B to A, even though the electron is flowing A to B. Now you might think that's stupid, and you're right, it is stupid.
Why?
We'll get to that in a moment. Okay, continue. So the question now is why? Because we call electron negative and protons positive. So what on earth do I mean by that? Well, we call protons positive and we call electrons negative, but that's just our name. For example, which hand is this, left or right? Left, and this is right. Now, if I call this left and I call this right, and if everybody does that, then that's okay, because it's just a name. Yeah, it's just a name. We called protons positive. It would have been better if we called electrons positive, because if we called electrons positive, then the electron flow and the current flow would be the same. So why did we call electrons negative if positive was better? Well, you can read this comic later, but the reason is because of Benjamin Franklin. You probably know him. He's the guy with the kite in the lightning, and the lightning hits the kite, and then the key in the jar. You know this? You know this story? Yeah.
The discovery of electricity?
Yeah. He called the charge, the electron charge, negative. Now, at the time, people didn't know what an electron or a proton was. But unfortunately, when people knew it, it was too late. So this is the reason. It's just bad luck that we call electrons negative. It would have been better if we called them positive, but that's life. Okay, so now on to some definitions of current. So you might, if we're talking about current, where's the plug? Here. You might have seen on like your phone or something this unit called the amps. It's how much current you get. So amp, 1 amp, is the constant current. Okay. So before I give you this definition is a very formal definition, which is, I don't think it's on the exam. So I'm going to give you this definition. It won't make any sense, and we'll explain it later in the course. So for now, you can just write it down and then forget about it. For now. You know what? No. Don't write it down, but at least make some note in your notebook that later you should look this up, okay? Or watch the video. But I think it'll be too distracting if we look at this now. It's not something we need for the exam. The definition is very formal, and it's something more suitable in semester 2. So I'll just leave it on the screen. You can watch the video later to write it down if you want, but we don't need it for the exam, okay? But what you do need to know is that the amp is what measures the current. So, big amp, big current. Yeah, you can get the definition later.
1 second.
1 second? Alright.
2 seconds. Okay.
Oh, you want ampere? Yes. Okay, now what's more important for the exam is the Coulomb. The symbol is C. And it's the charge when you have 1 amp in 1 second. You don't use coulombs in chemistry, do you, for charge? So what's the charge of a proton in chemistry? You just say +1. And what's the charge of an electron? -1. Now we don't do that in physics. We have a unit for charge called the coulomb. It's the SI unit for charge. And 1 coulomb is when you have 1 amp for 1 second. This is 1 coulomb. Um, Yeah? I'll go back to this. I just want to draw it for you. So what I'm saying is, if you have 1 amp for 1 second, so here's our wire. So you have all the electrons here, and 1 amp, so this all moves to the end here. What you get at the end is 1 Coulomb of charge. Now I want to... Has anybody got a plug, like for their phone? A charger? No, not a charger for their phone. No, you must be joking me. Somebody must have a charger for their phone. Nobody.
You can use any plug.
Oh yeah, but I'm kind of using it right now.
Yeah, I'm sure.
No, it doesn't say it on this one. Oh, there, it says it on it, but you can't see. No, this is not a good example. But can you look? If you look, if you look at a plug, you can see the current is in amps. So the limit for this is 13 amps. That means in 1 second, 13 coulombs of charge can come out. That's the limit. So in 1 second, 13 coulombs of charge could come out. 13 amps, that's the limit. Okay? And if you check your phone when you go home, it'll probably say something like 250 milliamps. Yeah? Right. Do you have this definition now?
Yeah.
So as a formula, the Q is for charge and the I is for current. So the total charge is the current multiplied by the time.
What's the triangle?
It just means small time and small current, although it doesn't have to be small.
So what is
If you want to write Q equals IT, that's fine. Q equals IT. This is the charge, this is the current, and this is the time. Yep. Have you got that? Yes?
I is current.
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 Now, yes, what's the units here for charge? What do we measure charge in? Coulombs, and current,
Ohm,
amps, and time, seconds. Okay, got that? Yep, right. Q is the total charge, I is the current, and T is the time. Finally, how big is 1 Coulomb? Well, 1 Coulomb is a lot of charge. It's a lot of charge. Because for a proton and electron, the charge is really small. 1 electron has a charge of minus 1.6 times 10 to the minus 19 coulombs. So 1 electron has a very small charge, and we often just write that as E, or minus E, I should say. Or minus 1 in chemistry. So I think the number is important here. For an electron, that's how much the charge is. And in chemistry, you call this minus 1.
Electron is the same but with positive.
Yeah, proton, yeah.
Proton.
Yes,
just write as E or minus one.
Oh yeah, so this number here, you can write it as just E, or minus E I should say, minus E, or in chemistry you call this minus 1. An electron has a charge of minus 1. Now the reason I'm doing this is because minus 1 has no units. So in physics we need to be careful about this. We don't say minus 1 charge, we say this much charge. You got the idea?
Is it important?
The number is important, the 1.6. Yeah?
Yeah.
Okay, continue?
Yeah.
Yes? Perfect. So I only have this one question to do, and then we can finish. So can you write this question down? 100 milliamp current is flowing through a copper wire for 2 seconds. What is the total charge that moves during the 2 seconds? Yeah, but let's calculate it. Can I do it now? Amanda?
Yeah.
Yep. Okay. So what is the here it is here. The current is 0.200 amps, and the time 2 seconds. So the charge,
Why 0.200?
This is a million.
milliamps.
It should be 100.
Yeah.
0.1.
Oh, sorry. Thank you. Somebody's awake. 100. Q equals IT, which will be 0.200 coulombs. By the way, how many protons would that be, for example? Well,
Isn't it the same?
yeah. No, I'm trying. Don't confuse me. Tell the truth. By the way, that is like 1.25 times 10 to the 18 protons. Now, it's not quite like protons because what happens is, remember we said it's the electrons that move. So here, which way do the electrons move? From the right to the left. So this is like 1.25 times 10 to the 18 electrons moved to the left.
Isn't the final answer just 0.
It is, but I'm trying to expand your mind.
No, but let's not specify to the left or to the right. We can say from positive, negative.
Yeah, I should say opposite direction, but in my picture it would be.
So saying protons and electrons same or not?
Yeah. So it's like that many protons move right, but it's not the protons that move. What moves? The electrons. So it's the same number of electrons moving left, though. It's the same thing. Oh, look at this. Exactly on time.
Do we have homework?
42. And then I'll show you the homework.
Did you try something?
Did I what?
Try.
Not yet, sorry. Sorry.
Such
I'm so busy. Okay.
What do you talk about some listening one?
I'm so busy.
No.
What?
I mean some listening.
No, nothing. I didn't say anything. Forget about it. Forget.
Should
Forget.
we? No.
Forget.
I mean, should we know in the future?
You will know in the future.
No, I don't want to.
Definitely greater than listening part.
It's not some great thing.
No,
Yeah,
forget.
This
Forget.
something come out from
Forget.
human.
Forget. Alright. Finished?